In this video, we are going to talk about how to calculate the distance from a point to a plane. Let's get started.
We have understood the equation of the plane in previous video. Now let's understand how to compute the distance of a point from a plane. This has been used a lot in various algorithms. Let's assume I have a plane pi and let's assume it passes through origin. We know that the equation of the plane which is passing through origin, we can write it as W transpose x is equal to 0. It means your vector W is perpendicular to this plane. We have seen this in previous video. If you have not watched that video, then please watch it. Link has been provided to the description. Imagine if there is a point P. If we are considering as n-dimensional space, then it has n components. Now I want to understand what is the distance of this point from the plane, which means I am trying to understand the shortest distance here, right? So I draw perpendicular from this point to the plane and we will find the distance d here. Here we know that W and P both are column vectors. By default we consider them as column vectors. So here D would be W transpose P divided by norm W. This is the equation of the distance. By the way, we can prove this equation. Right now we are not proving, we will just use this formula. Please leave a comment in the comment section if you want to know how to derive this formula. Now let's assume I have 2 points P and P dash as mentioned in this chart. Here P is one side of the plane and P dash is on the other side of the plane. Let's assume the distance is d dash from the plane to point P dash. Question here is, since W is in above direction and P is also in the above direction, so vector P will look like this red arrow. Here D is nothing but D equal to W dot P divided by norm W. If W is unit vector, then norm W would be 1. We can discard this denominator because it's always 1, right? Now the angle is theta between vector P and vector W. Here the angle is less than 90 degree between W and P. So W dot P will be positive, right? Since W and P are on the same side of the plane. Remember, plane separates the whole region into two parts. One part is above the plane and one part is below the plane. This region is called the half space. Line in 2D separates into two half spaces. Similarly, plane separates 3D coordinate system into two half spaces. Similarly, hyperplanes creates half spaces in higher dimensional space. That's what a half space means. If you take a whole area to be a space, then half space is something that you get when you break that whole space by any linear surface like line in 2D, plane in 3D and hyperplane in ND. Now let's understand what is happening here. So D equal to W dot P divided by norm W and D dash is equal to W dot P dash divided by norm W. Since this angle is less than 90 degree, since W and P are in the same half space, so W dot P will be positive. Angle between W and P dash is this theta dash, which is greater than 90 degree, which means W dot P dash would be negative. Because what is dot product geometrically means? It is nothing but W dot P is equal to norm W norm P into cos theta, where theta is angle between W and P. Of course, what is the negative distance? It means nothing, right? Because what you do actually, when you have to compute distance between a point and a plane, is you take the absolute value. So distance would be always positive, but the sign is extremely important here. because it tells me whether the point P is in which half space, in the same direction of vector W or in opposite direction of vector W. Means for all the points which are on the same direction of vector W, which is normal to the plane and passes through the origin, their dot product with W would be positive, and for all the points which are on the opposite direction of vector W, their dot product with W would be negative. Dot product is really very important in linear algebra and machine learning. Whatever we are learning in 2D, it holds true for any.
That's it for the video. If you like the video, then please provide your comments to the comment section. Thank you for watching. This is Gunjan Varde signing out until we meet again.